Good morning, everybody. Thanks for coming. Today we're going to share some of our experiences and talk about sort of 10 things to know about managing and operating services in Google Cloud. So I'm Preston Holmes. I'm a product manager in Google Cloud. I've actually been here maybe close to 9 years now, and prior to that in Amazon. So I've been in the public cloud space over a decade and have seen and helped quite a few customers move from various circumstances on the cloud, and so that's my perspective on these 10 points. And I have Ram.
Hey everyone, good morning. How are you? Hope you all are having a great next session. Thanks for attending our session. My name is Gogineni. I'm a principal SRE architect at Charles Schwab, responsible for the entire observability strategy and implementation. Day-to-day, I work with several SRE teams in taking care about high availability of our applications, resiliency, whatnot. Entire SRE thing will be running with all our partners.
So when you look at the cloud, sort of the journey to the cloud, right, it's always going to be a little bit mysterious. And I kind of make an analogy to parenting. So any of you that are parents know that there's simply unknowable challenges that are in the future, and that you're never going to be prepared ultimately for the challenges that come. You simply need to be adaptive and respond and learn as you go. And this is true of the cloud journey. I think most organizations set out thinking they are going to make a plan and that the plan will in advance take care of every sort of foreseeable thing. But the truth is it's still a very large and very complicated process. The documentation, the training, all these things help, but at the end of the day, there's going to be no substitute for the uniqueness of your journey.
Yeah, as I said, I'm from Charles Schwab. Here is a little bit about Schwab and who is Schwab, what Schwab does. And I would like to, take to what Preston is saying about the cloud journey is complicated. Definitely it is complicated, but the more you start doing into the journey, right, with the best principles and all that stuff, it gets better. And currently Schwab runs a variety of critical workloads, that ranging from data to already GKE workloads, anything. There are several workloads running in cloud. However, as we started, initially the journey will be tough, like any other thing, as it involves several stakeholders, from your development team, QA, networking, everybody. The first thing is making sure everybody is onboarded to the same mission, okay, everybody together on this journey. And also, in the strategy, making sure you're identifying the right application for the migration, and beginning from the application identification all the way to your last mile of how do you, migrate from either from data center or from other cloud partner to complete the last mile. So that's where first you need to buy in the entire stakeholders. Also, don't assume that your first architectural blueprint or document would be the one that is going to the production, right? As part of the journey, you need to review and see what are the trade-offs between the applications, what needs to be done. For example, nowadays all these microservices run either on, if you want to go in GCP, you may choose to run either Cloud Run or GKE. You may start with Cloud Run and then, depends on the workload, not necessarily don't have to go to GKE, but Cloud Run. So the whole point is you got to be flexible, be agile, and learn as you go, and the ability to change your stuff so on the fly. That will enable you to set the strategy right and have a methodical approach on how entire migration, it could be a data, it could be an application stack, everything need to be together for a successful cloud migration journey. Today, as part of that, I came here to share some of the learnings for one of the critical application we hosted in GCP. It's called Client Authentication Application. We have a suite name called CAKE, Client Authentication in Cloud. So what it does is, the authentication, it authenticates a multi-millions of logins every month. And it has several, based on the workloads, right, it has a peak. If you look at some of the retailers, they may have peaks during the holiday season. And yesterday I attended a Papazon talk that talking about Fridays are their peaks, right? Friday evenings are their peak. However, for Schwab, every day, the morning during the market open and evening of the market close, those are our peak workloads. So we got to be ready to support whatever the peak we are getting. So that's one of the reason, for the agility, elasticity, also the scaling, we chose GKE as our core application architecture and ability to run, across the workloads in multi-region setup and all that stuff. I would like to spend a little bit more on this diagram, which has more inferences in, of the topic. If you look at here, the entire GKE running in GCP, there are, as we are in the journey, not necessarily we're able to migrate everything to the cloud once. It's a journey, right? Some, still running on-prem. So we talk to the on-prem services, the data center services. Also, if you look at down the logs, we made an architectural change in such a way that given this hybrid workload mode, some cloud native as well as some on-prem, we are bringing all these logs together to GCP to take the advantage of in the scale of GCP so that we can get a single pane of monitoring glass view and ability to identify the issues quickly and all that stuff. So those are the couple of the high-level architectural points. This slide is very busier slide in reality, but it's stripped up, to show the high-level stuff. So, yep.
Great. So we're going to now kind of talk about 10 things. And these aren't, we actually, the original title of this talk was the top 10 things. And we took the word top out, right? Because we're not going to presume to rank and order these. These are 10 things that in our conversations we thought would be something interesting to share about some aspect of what we've learned matters or doesn't matter in this. And we're going to take sort of a format to each of these things. And what it'll start with is just a general quick statement of what the topic is and in sort of a cloud vendor agnostic way. Then I'll try to talk a little bit about what I see as some of Google Cloud's opinions or best practices or maybe some of the lesser known elements. Again, it won't be comprehensive. We're not going to cover each of these topics to their nth degree. And then Ram will talk a bit about Schwab's own opinions at a company-wide level as a cloud organization, how they look at that topic. And then we'll use that application he just described to talk about how particular decisions get made all the way down, sometimes at that application by application level. So the first is going to be resource hierarchy. Now, any cloud vendor is going to be largely infrastructure via APIs, right? It's an API-driven system, and these APIs create resources. These resources are always grouped or bound together into some sort of containment system. These might be workspaces or projects or folders. In some places, they might be just by account. So how these cloud resources are organized and grouped together is usually something that is deeply ingrained into the way any given cloud vendor presents its products. And these choices that you make about how you organize your company's usage of cloud in that resource hierarchy is often a very sort of permanent and foundational decision. In other words, it's not something you easily want to go back and change 2 years later about how you sort of embrace a given resource hierarchy. At GCP, our resource hierarchy really starts with a cloud organization. And most companies have a single cloud organization as part of their usage of GCP. There are larger companies where they have, say, very large acquisitions or divisions that operate more as a subsidiary where they might use multiple cloud orgs. And then within the organization, we have folders. And the folders are really just nodes of a hierarchy. They don't really have much other than as a point of attachment for things like policy. And then the real atom of the GCP resource model is the project. And the project is the thing that contains a cloud resource. Every cloud resource, every product makes things happen in cloud projects. And this hierarchy is something that you can use to attach things like policy to that have inheritance down to the lower levels of the resource hierarchy. And so how you use folders and organizations and how you use those to attach policy, we'll talk about policy a bit more later, is really key to sort of how you choose to use GCP.
Absolutely, Preston. In GCP world, project is the key, right? All the resources are in the project. We do follow the similar approach, kind of the same approach at a org level, folders and projects. Also, the way our projects are organized was it's more at a business component level, right? Business transaction. The same inference we can go back to client authentication, which is made up of several logical services made up of authentication. They are all grouped into one application ID. Internally, we call it as application portfolio management. Based on the APM ID, the projects are created. And these are followed through all the way from sandbox to dev QA, all the way to the production. That's the approach we followed. And also everything is driven through Terraform. It's easy to create a project and take down a project. And at some point, if I need an additional project for do some testing, right, or something else needed, it's kind of like, one pull request, you would be able to spin up a project quickly, and I'm done with that project, then you can tear it down. So there is a lot of flexibility, the way how Google organizes the projects, and also the resources within the project as well. So it's very helpful.
Now, when it comes to sort of structuring permissions and policy, I think this is, again, any cloud vendor is going to have mechanisms and tools for this. At the end of the day, this is really about trying to find the balance between control and sort of flexibility and permission to be, productive in whatever you do. And that is a balancing act. You can overdo this if you sort of over-apply overly complex permissions and policy. It can become a burden for the workforce, right? But so it's a balancing act between those two. I'd also like to kind of be, a little bit of a soapbox around some of the security features in that overly complex security setup can be a security anti-pattern, in my opinion. Meaning, if you have a security setup that very few people can reason about or make sense of, that actually becomes something that is very hard to monitor whether it's doing what you want to do. And so we have in cloud vendors many tools and many capabilities, and those should be applied sort of in the appropriate ways where they apply. So now in GCP, we predominantly have two main dialects around this. We have IAM, which is really around resource access and permissions, and that really gates usage of the API on the different products and services. And then we have organizational policy, and organizational policy is really more around capturing the intent of governance and management around practices and guidance around how to use products. And both of those can attach to the resource hierarchy. We generally believe that you should structure things like permissions around roles rather than always around individuals. This makes managing the permission of individuals easier because you're talking about membership of a group rather than having to kind of keep track of individual policies of IAM applied to individuals. Lastly, there's always going to be some choice about that shared responsibility with the GCP as a customer. So for example, we do offer many managed security features that I think are advantageous for to let Google do sort of the management of security, things like keys, but we do allow you to do things like bring your own keys through customer managed encryption keys. And this is all about picking some choice you have on a trust boundary with Google. So you may trust Google more to manage keys, or if you want to do more of the key management yourself and take more of that burden on, you can use something like the customer managed encryption key. So those are all choices you need to make around an adoption of a security model with the cloud vendor, because it will always be a shared responsibility model.
Thank you. So, if you are into the very early stages of the GCP into the world, the IAM could be overwhelming and daunting. It's very confusing also to start with. What are the different permissions needs to be applied, which groups, layers and all that stuff. After a while, they definitely, once you get a hang of, then you know exactly how these are works. But the best practices, we do follow also, industry level will be the AD groups. Based on the project, you may need a different groups of users, right? Some could need only the viewer role access. Some could be the editor role. Suppose a security team, audit team, they need only the viewer access, right? All these managed via the AD groups. The groups has, required people. Suppose, 4 QA people will be one group, a developer will be another one, SRE team will be in another group. So that's why you set up your own group and also create the appropriate roles in that group. That way, you have the right roles set up in that group. One other thing, we truly believe that the privileged of least privileged access for any group, right? You don't need then what is truly needed to perform that job. So just want to make sure the required permissions, least privileged access is given to any group so that the entire security posture can be managed very well.
So we're going to talk about quotas. Now, quotas are not anyone's favorite thing in general. I think quotas are something that in systems, now we have quotas internally. Internal systems, all at Google, all also use quotas. This is not something just externalized in sort of a cloud services space. And they're really to protect everyone from unforeseen usage at the end of the day. I think the key thing with quotas is to be proactive and in their management and not be reactive when you start running into issues. Now that means being familiar with the nature of them, because different quota systems apply to different products using different kind of measurements of a window. So some quotas are sort of based on a pure absolute number, other quotas are more time-based. So being familiar with each product you're using and the nature of the quotas. In GCP, many quotas are actually auto-approved based on your own sort of usage of cloud. If you're sort of a good, like long-standing user of cloud and you're paying your bills, et cetera, you have essentially a lot of your quotas will be auto-approved. Other quotas do require human review. And it's important for you to monitor the consumption of quotas so that you can be proactive ahead of the time they might come up. Now, the final thing I'll say is that any significant large project, like when we're dealing with a very large retailer around Black Friday or a broadcaster around a major sporting event, these always sort of will require some degree of conversation with an account team. We often set up very collaborative sort of of large event management teams to make sure we're doing the right kind of load testing and capacity planning, et cetera. So the day-to-day usage of quotas is sort of one thing around this sort of ongoing proactive measurement, and then I'll say special events require special attention, and that's absolutely something we do.
Thanks, Preston. Always the quotas are, an interesting topic. So on how these will play a role. So I think, in the early stages of your development and all, right, we should be able to identify what is the truly required quota for each service for your critical workloads in production. Suppose, I need to run these many logins per minute in that, right? So that what are the different things we need to be making sure, maybe the logging API, BigQuery or any VMs or GKE, right? All these quotas do play a role. And if you go to the Google Cloud Console, there are 13,300 or something services available where you can configure the quotas. So it is very hard to know, right, which one to pick or which 10 I need to set the quotas. The way we planned was and we did was in our lower environment, when you run this, the performance test, that's how you know, right, what is the scale you need to run this application. Then you run the performance test and to the scale what you needed and go back and look at your quotas, right? Okay, where are my quotas around this? Also, you may put some threshold about that. I always like to know when my quotas are approaching around 70% or 80%, and then create an alert on top of those, right? That way, also there are better dashboards available for quota management as well. But the key is identifying the required quota. I can take a couple of examples, real life where we, see it and also later we found it. For example, if you take the BigQuery, and BigQuery has as by default, it has unlimited data query for a day, right? There is no limited BigQuery usage per day. I mean, one way it is good so that, nothing is stopping, but really not sure, right? Unless, say, like you have hundreds of users, each one using to an extent, then that will add up your quota. So, and also there is one more level deeper. There is a BigQuery usage per user per day. Say like you have 100 users, each one is using like 100 terabytes, then that will quickly add up, right? So depends on the use case, what you're trying to do. You may want to clearly look into the quotas for each service and configure appropriately. That way, accidentally you won't run into impose your application, stopping your application in the middle of doing something, or adding more cost to it. So always quotas needs to be reviewed monitored and alerted. That way you have a right way to manage them.
All right, we'll talk now about log management. So logging is obviously probably the oldest form of application monitoring. I mean, everyone who starts development starts with some level of print debugging, and those become logs, and then logs become more sophisticated over time. There's never been more logging as there is today, and I think each day that becomes an equally true statement. So not only is there more logs being generated from more sources, but logs are changing in their nature. So one is that logs are increasingly highly structured, and structured logs provide a much richer source of information about the systems that they are logging. Also, logs are becoming increasingly useful beyond simple operations. So logs have a lot of information that are increasingly relevant to the business and the products that they're associated with. And so, the origins of BigQuery in many ways at Google were about our internal logging problem. How do we manage logs at scale at Google when you had the first sort of iterations of Google where we were getting into hundreds of thousands of servers? And so in Google, we do have a lot of tools around centralizing and storing logs, and that's often our recommendation. Ram has done a lot in this space, so I'm going to let Ram talk more about what Schwab's done.
All right, thank you, Preston. You may need to warn me, either logging or troubleshooting. I will keep going and talking for hours. So, so definitely logging, it's a very interesting topic. As you start running your workloads, it produces various types of logs, system logs, application logs, networking logs, VPC logs, right? You got to be really understanding what are the different logs that's coming to your project, and what is the true needed logs needs to be in your project. First, identify the logs. Suppose your application is chatty, it is writing so many logs, you may not have enough time to fix it, but however, the way you would do is, once it comes to the project, from the log sync, you can drop the logs or unwanted logs. So first key is identify the required logs. If you take about the VPC logs, it has tons of logs. Obviously, they do some kind of the rate of sampling. Even on top of it, it produces tons of logs. So if you are not careful about it, it will faster add up. Your log buckets will increase. Also, it will add up so much of cost as well. So first key is identify the required logs. Then drop the unwanted logs, not even reaching your cloud bucket. Second one is, how do you manage your log life cycle? Okay, I know what are the logs I need it to be. Then how do you keep them, right? Maybe there are different purposes for these logs. One could be for operational, for troubleshooting. Some may need a lifetime of either 30 days or 60 days. That is the default. Google provides 60 days in the Cloud Console. And later, maybe for various reasons, could be for audit purpose or for the analytical reasons and all, you may want to find the target state of these logs. Some can go to a GCS, some may go to BigQuery. If you chose the route for GCS for audit purpose or something, then you need to identify what is the long-term strategy, right? Do I need to bring them very often, or it can go to the cold storage versus near-time, real bucket and all that stuff. Also, if the policy of you're storing the logs is more of an analytical reason, BigQuery would play a greater role here. Especially you can store them, also bring as needed with some other analytical tools on top of it. So, when we did some comparison, right, I think with the BigQuery compression available and all that stuff, the cost also in GCS and BigQuery, there is not much of a difference, so you can use that as well. Also, one other thing I would like to talk about is, all these microservices, they may span across the projects. So then, and your services is in one project and you are consuming few other services across the project. Then how do you get the common visibility into these projects? So the approach we took was, creating a common logging project where all the logs would go to one centralized logging project. That way, you would have an access to the projects. Also, those logs can be controlled via the log views. Suppose a project A not necessarily have an access to the other logs in that project, however, they may some. This can be controlled via the IAM permissions, log views. Also, you would be able to restrict some of the logs even at log field level restriction as well. So that way logs plays a critical role in this entire cloud migration journey and all. So definitely a lot of thought needs to be put in place for proper log management and life cycle of it. Thanks.
Now, closely related to sort of logging in this ops space is troubleshooting. One of the challenges often in a cloud platform in troubleshooting is you do have limited visibility into the internals of some of the systems you're using, right? So it's often important to recognize that if something is going wrong, sometimes the first place you need to check is the vendor status dashboard, right? Because it might be that there's a product level outage or something degraded. Now, I will admit something. The way any vendor is exposing something on their status dashboard is based on a threshold. And because products don't simply go offline always in an all or nothing way, you often have degraded conditions in a cloud service that do not make it to the status dashboard because you might have a condition where you have, say, 4% of customers who happen to be in this part of a data center who happen to be trying to do one operation on that product are hitting an issue, right? That kind of degradation usually doesn't rise up to a status dashboard, and that can be frustrating if you're seeing a problem, but it's not listed on a status thing. And that's really where if you have the support team and you have the connection with support, support can look into your projects and your resources and help clarify whether you might be being impacted by what is sort of a sub-threshold condition within a product. So know that that is one option sort of beyond the status dashboard if you have the right kind of support tier. When it comes to understanding the root cause, I really just sort of want to use this moment to be a proponent of distributed tracing, right? When you have complex data paths going through multiple cloud products and your own potentially multiple cascade of microservices, and you're seeing an end condition of, hey, we're seeing really slow response times, why? Asking that question, why is this certain service slow, is usually about drilling in and figuring out which part of the 12 to 15 things it might be doing is potentially most contributing to that slowness. And distributed tracing, while it does take a pretty significant investment to put in place to instrument the code, is by far one of the best ways to see where in this call path latency might be introduced.
Thanks, Preston, for the deep insights. Yeah, troubleshooting is my daily job and my favorite topic. So, and as you said, right, in the initial day itself, our architecture, given we have workloads running hybrid workloads, cloud native as well as some to the on-prem as well. The architectural choice we made was to bring all the logs into GCP to take the advantage of our scale of GCP. So then we are having all of our logs, including our logs as application logs, as the correlation IDs, all that stuff. Everything is in one central place now, which is in the GCP cloud operations, in the log buckets, analyticals, and BigQuery. So the key idea here is how quickly you can identify the issue. Like, the quicker MTTD and MTTR. Those are the key things, right? You should have an ability for your SRE teams and quickly detect the issue and the ability to take an action so that you can restore the system quickly. So the approach we follow, from several years, we are doing the same thing, our data center as well. The same principles we are being applying. Each of our critical or any service, we monitor those SREs, golden signals, latencies, traffic, errors, and saturation rate. And we built, our SRE team did a phenomenal job in building several dashboards, which has these golden signals. And the approach we took was it's kind of a 3-layer. We have these business metrics, application metrics, and infrastructure metrics. Maybe let's take a step back. What are the business metrics? Why do we need that one? Okay, your entire system is built to do a business function. Is it really doing what it's supposed to doing? So at any given point of time, I'm interested in how my authentication app is working, how many logins it is authenticating, or how quick it is doing, and what is the peak rate, how can I go back and look back? What is my yesterday's login rates compared to prior week or something, right? These are all the different business metrics. We should be able to bring it back to your dashboard. And then if you go another level is the application metric. In order to provide that business value, how my application is performing. What is the latency each user is experiencing? How are the error rates are working? Or any other deviation is happening in the application. Those are all driven through the application dashboards. And one more level is the infrastructure. That's where the saturation comes, CPU, memory, error rates, and all that stuff. So to get into one common view with all these three metrics, give a quick view for any SRE engineers or our command level control people, able to quickly identify and then take next steps. So we built several log-based metrics. Given we are bringing all the logs into the GCP, entire GCP is driven off of the metrics. Several log-based metrics were built, which ported to the dashboards. And each dashboard or the metric is tied to an SLO, which internally has SLIs and all that stuff. So given through this SLO monitoring, also, the critical alerts are created, which will go to our level 1 command center and all that stuff, if needed, directly paging and all that stuff. So in that, we have an ability to, you get a lot of alerts sometimes, when you are into the early stages of the journey, especially when you changing the monitoring tools, right? Suppose, you have the on-prem have one tool and then move to the GCP, you may using different tools. Also, in the beginning days of the journey, you may put more threshold ranges. That way, you are monitoring. Sometimes they could be aggressive, sometimes, a little more relaxed. So there will be a lot of noise in the alerts to begin with. But you got to be, look into the carefully and, soon adjust those alert threshold. That way, you have the right alerts in the pace, able to do quick actionable, and don't want to get caught into the, alert noise or alert fitting, all that stuff. That's another thing helping us. Also, I want to give credit to the Google team as well. In the last 2 years, there's a lot of improvements done in the Google Cloud Operations Suite, especially the Logs Explorer. Also, the Log Analytics is the one which is still growing, but there are a lot of features coming in the Log Analytics where you don't need to really go into the BigQuery, but from the Logs console itself, ability to do the queries as well. And all of our logs today, they go to BigQuery as well for analytical purpose too. And we do use the log sync to get that one. But however, given there are some challenges, the way how the logs will go to from the Log Explorer to the BigQuery, it will identify the first record, sets the schema, some of the issues with challenges. So Log Analytics is the one solving those. So with the combination of, the planet scale of some of these Google tools, and the great work from our SRE team with the principles of what we're adhering to, helping us to troubleshoot the issue and able to run this scale of application, the critical application, without any incidents and all that stuff.
All right, we're going to say a few things about cost management, and I'll start with saying that cost management continues to be difficult on the cloud. I think first and foremost, this is really because the models in the way cloud is built for, largely in these sort of metered and consumption-based patterns, is very different from the way most companies' finance systems operate in terms of procurement and budgeting and planning. And so there's a lot of things that, when moving applications to the cloud means adopting to how you're going to plan, forecast, and model the cost of given application, which may have many, many dimensions across different parts of the cloud, such as network storage, et cetera. One of the key things in terms of how we see companies modernizing the way they approach cost management is to really adopt this process of FinOps, this idea of operating and automating more of the way you manage and monitor and analyze costs, right? So in GCP, one thing that has been a good practice for a long time is to use tagging on resources that you can use as a way of aggregating resource billing to particular projects or business units, et cetera. So tagging is extremely useful. Also, all of our billing data, when we've been talking about the types of logging and analytics you can do, is also exportable to BigQuery, right? For where you can build dashboards, et cetera. And then finally, I'll just say that when building complex applications on cloud, there's really almost no substitution for running the load tests of what it would look like to actually run the application and then using that as a snapshot to do an approximation of what your billing will be at a given sort of usage volume.
Yeah, thank you, Preston. Definitely costs, we got to be really cognizant about what kind of workloads you're running in cloud and how they are running and also why they are running, right? And, especially in the early stages of, we're still in that on-prem data center. Maybe how many of you can recall the last time when you decommission a server because you are not really in use, right? We let it go. Or it's not our problem. Somebody will take care about, decommission the server because we are not paying or somebody else is not paying, right? So here you got to be really understanding about what are the workloads running, why they are running, how they are running, have, complete monitoring on those. Google has a good way to monitor, the cost as well based on the SKUs your components using, how much is the BigQuery, compute, and all that stuff. Also, if needed, there are third-party tools also it supports with billing API and all. You're able to get into one common place. If you have to compare with on-prem versus all these costs, the way how I feel is, once you onboard to any public cloud, it's like you're getting into a, olden days taxi, which is running a meter on, right? Unless as you are on the car, the meter keep running. You can't sit on the car and forget, right? Similarly, you have to, keep tracking and what is running and ability to, most of the time, you start your development in a sandbox or something and you move on. You may not necessarily stop it, it keeps adding on it. So also, you may start running some workloads in production. Maybe you have to really analyze and observe it. Do you truly need it to run that scale or something? Or there are opportunities to optimize, like schedule scaling versus pre-scaling. Sometimes need a peak load at a certain point of time. The rest of the day would be very normal. You may not need it. So all these things needs to be considered. You got to remember everything what you're running or plan to run has a cost to it. Nothing is free in cloud.
Well said.
Sorry, Preston, I may be taking it.
No, that's good. All right, so this one is sort of an interesting grab bag, and that is that in adopting cloud architectures, there's often going to be trade-offs in your application. In other words, people often say they want, the lowest latency with the highest durability with the, the greatest degree of resiliency, but there are trade-offs in the way you design these systems, and sometimes they require balance. I think it's always important to make these choices based on your user's experience, whether that's an internal user or an external user. In other words, there are some experiences that don't require the fastest latency. Do you need something to be responsive within 100 milliseconds if it's a batch data processing job? Probably not. In this area, when it comes to resiliency, one important thing in GCP is to recognize that different products have different sort of geographic default distributions in the way they are managed. So there are some cloud resources which are inherently zonal, some that are regional, and some that are multi-regional. And so as you're building your system, recognizing which model each product is sort of adopted in the way it's automatically managing resiliency is important, that you kind of don't build a system that, say, uses 3 regional components and 1 zonal component, because now your whole system is going to be only as resilient as its least resilient component.
Yeah, thank you, Preston. I would like to spend just a quick thing on the resiliency. So the way how we approach this was, based on the criticality of our application, right? Internally, we have an operational risk rating. All our apps are categorized, what is the risk or, the critical application and all. Based on that, our architecture is said, okay, you need to run in a multi-region, multi-zonal setup. That way you would be able to, at any given point of time, our goal is to be able to serve this application, the peak loads from a single region or also within a single zone. So, that way, we are fault tolerant, unless it is truly needed, we don't want to go to, the DR zone or something. In some cases, we have a multi-region workloads also running, active, some could be, active and warm standby, all that stuff. But the goal here is, you have the resiliency built into it at a regional level, also at a zonal level, ability to support the workload.
So we'll move along pretty quickly. I think we've got a few more to cover.
Sure, yeah.
So this one is really just to recognize that when you are moving from a traditional environment to the cloud, that data and the choices in databases and things like that are really wide open, right? I think a lot of systems in the past have assumed that there's a database and that's going to be a one-size-fits-all database and all applications are built on that database. In the cloud, you have many choices when it comes to data, and really a single application might use multiple database systems depending on the particular user journey within that application that is being served. So my point here is to sort of embrace that, recognize that different facets of an application might benefit from different types of data products, and to pick the right one for the right job within an application.
Yeah, I totally agree. We did the same thing, based on the true need and use case. We adopted, to the data diversity and all, several databases, also caching components, all that stuff. Also for analytics, we use the BigQuery. That is one of the way, based on the need. In the past, our analytics are done in the monitoring tool. Now they are moved to, the planet scale BigQuery. That's where you take, available product and approach as needed.
So as a company is embracing a cloud, the cloud itself becomes this very vast source of information, both from an analytics point of view as well as an operational, like event-driven point of view. So many of the cloud products and cloud systems, like I had mentioned, that billing itself can generate queries. Ram has talked about things like VPC logs. These all provide a lot of information in the way you're using the cloud and should be analyzed the same way your application is analyzed for performance. The other thing is that in GCP, we have a system called EventArc, which is generating events for every audited log. And in the future, this will actually be generating events for almost any API operation. And so automating and sort of treating this as a programmable cloud itself is a great way to adopt maybe new types of architectures that you may not even yet be adopting in your application, such as event-driven architectures. Doing that for your cloud operations is a great place to become more effective and more efficient in the way you're using cloud.
I agree, Preston. There are several opportunities available, to take the advantage of truly the automation way, right? Each event-driven, then do something, right? It's all kind of, to keep your system up to date, all that stuff. Also, taking the opportunities. Say, for example, we have, all of our data is coming to BigQuery, including, metrics, how the system is performing. The one thing we are looking at is, how do, cloud providers to run the cloud, right? The capacity on demand, right? Capacity at scale, how to identify the required capacity. So since the data is in BigQuery, we are exploring how to do some of these models, like the standard ARIMA model, arithmetic regression model, or something that should tell us what is the capacity I needed to run my application for the next week versus next month for the peak loads and all that stuff. There's a lot to come on that front.
And finally, we have how to learn effectively. We talked at the beginning that the cloud journey is always going to involve extensive amounts of ongoing learning. So a few of sort of the things I've pulled out to talk about here is one, really make sure at Google Cloud you can learn a lot about the way all products work by learning about the way we design and build APIs. So we've got a lot of public documentation about things like gRPC, protocol buffers, and even our own API design guidelines are publicly published. So kind of learning that once gives you a lot of learning of all current and future products at GCP. The second is make sure your teams have the ability and freedom to learn and experiment. You have to be able to experiment to learn the way a product works. So make sure people have access to things like test projects and experimental projects, support hackathons and fun things to do to try new things with new cloud products in your organization. And lastly, as somebody who's now actually involved in the Duet AI stuff, I'll say, take advantage of AI to help assist, summarize, and find answers to problems when and where you need them. Because you can lose a lot of time, switching out of what you're doing to go chase down a set of documentation. And we're really trying to make AI something that can bring the answer of what you need to know at the place you need to know it.
I agree. Learning plays a critical role in any cloud journey unless your resources are really learned and know on where they need to operate, right? Otherwise, it's very hard in the journey. So as Preston mentioned, there are several Google resources available, great documentation, developer blogs, also the case studies from the customers, right? If somebody's already figured out how to run a GKE at scale, probably you don't need to spend so much of cycles of time or get an abstract and see how you can apply to that. And also another thing is, learning entire GCP, it holistically helps than, learning at small bits of it. One thing our leadership encouraged / mandated was, everybody in the project, ability to get the certification, either a cloud engineer or GCP certification, all that stuff that also helped us. I myself got like 2 certifications last year on that path. So that's really one good way to learn and take progress into the next things.
All right. With that, thank you all for coming.
Yeah, So I would like to take 1 last minute. As I said, the cloud journey is definitely very complicated. It takes a mountain of people, to run this. So I would like to take, 1 quick minute to thank each and everyone from our Schwab team. Including from our executive management, leadership. We have our great architects in place. Our management is already here. With all the helps from all the teams, we are able to complete this, migrated this critical application. I'm just happen to be one here, but there is an army of people behind this to making it very successful. Thank you.
Excellent. We're out of time. We'll be available in the hallway if anyone has any questions. Thank you so much.